Now we are going to discuss about electric field intensity. Now consider one charge fixed in a position, say Q1. So let it be, this is a charge, the value is small q. Now the flux will be emitting in all the directions like this, and move a second charge called as capital Q slowly around this charge. It will be like this. Now we note that there exists everywhere a force on the second charge. In other words, second charge is displaying the existence of the force field. The second charge is called as test charge. Now the force on it is given by E equal to F by Q, which is equal to, what is the basic formula for F? Q1 into Q2 divided by 4 pi epsilon naught into epsilon r into r squared. Here instead of the Q1 and Q2 we have capital Q and small q. Therefore F is equal to Q into Q divided by 4 pi epsilon naught into epsilon r into r squared divided by Q. So this Q and this Q is going to get cancelled. Therefore E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared. Now come to the definitions. We have two definitions. Definition 1, the electric field or electric field intensity capital E is defined as the force per unit charge and is given by E is equal to F by Q. We know the value of F, just substitute it and simplify that. You can get E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared. Here epsilon r is 1 because it is dealing in free space. In vector formations, E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared into AR vector. So here is also considered epsilon r equal to 1. The unit for electric field intensity E is volt per meter or Newton per coulomb. Definition 2, the electric field intensity is also called as negative gradient of a potential due to the charge, that is E equal to minus del V. Now we are going to discuss about types of charge density. Previous case you found this electric field intensity for the point charge. The formula is E equal to Q divided by 4 pi epsilon naught into epsilon r into r squared. But in practically they won't give for only single point charges. We have n number of charges. It is aligned either in the line form or in the surface form or in the volume form. If the charges are aligned in a line, that time we are saying that it is a line charge density. So the notation for line charge density is rho suffix L or lambda suffix L. Both the notations are used. If the charges are aligned in a surface, it is called as an surface charge density. The notation is rho S, or sometime we are using that sigma S. Next, the charges are aligned in a volume. It is called as an volume charge density rho V. Now these values are given. So in practical, for the point charge Q is given, for the line charge rho L is given, for the surface charge sigma S or rho S is given, for the volume charge rho V is given. Come to the line charge density, rho L equal to charge by length. So what is the notation for charge Q? What is the notation for length? L. Limit delta L tends to 0, delta Q divided by delta L. So what is the unit? So the unit for charge is coulomb and the unit for length is meter. Therefore the unit is coulomb per meter. From this you want to find out the value of Q, because we know the basic formula E equal to Q divided by 4 pi epsilon naught epsilon R into R squared. We required the Q value. From this one, what is the Q value? Here, this delta L, just look this delta L, it may be on DL also. Just look, here is a dq divided by dl, which is equal to rho L. Yes, so we require the Q value. Just move this term to this side. So rho L into dl, which is equal to dq. Just integrate on both sides, you are going to get the value of Q. So Q is equal to integral rho L into dl. Now, surface charge density. Surface charge density equal to lambda s equal to rho s. Sometimes maybe used this sigma s also. Sigma s, which is equal to charge per area, which is equal to limit delta s tends to 0 dq by ds. What is the unit? Coulomb per meter square. We want to find out the Q value. Q is equal to integral rho s into ds. So one thing bear in mind, here is a line integral, that is single integral. Here is the surface integral. So you have to put, here is suffix s, or you have to put, that is this is a surface s, or you have to put two integrations like this. Okay. Now, volume charge density. Rho v equal to charge by volume, which is equal to Q by V, which is equal to limit delta V tends to 0 dq by dV. This values measured in Coulomb per meter cube. Okay. From this one, you want to find out the Q value. Q is equal to volume integral rho v into dV. Clear? Now, you want to write the formula for all the cases. For point charge, E equal to Q divided by 4 pi epsilon naught into epsilon R into R squared. Here is distance is given. That means this is a charge Q, and you want to find out the electric field intensity at a point or at a distance P. This distance is R here. Now, for point charge, E equal to Q divided by 4 pi epsilon naught into epsilon R into R square into AR vector. Here, just look, this formula and this formula, the only difference is AR. How to identify which formula how to choose? If charge Q is given and you want to find out electric field intensity at a point P, now the distance between the P and the Q is R. So in this case, you can go for this formula. Suppose instead of this, this is the charge Q and this is the point P. They are given the point here. It may be on x1, y1, z1. So if they are giving like this, such a case you can go for this formula. For line charge, E equal to integral rho L into dl divided by 4 pi epsilon naught into epsilon R into R squared into AR vector. Just look here, what is the difference you are observing here and here? The only thing is, instead of the Q value, we are using that rho L into dl value. Just recall the previous slide. This is the Q value. Q is equal to rho L into dl. So we are going to substitute that value here. For coming to the surface charge, for surface charge, E is equal to, that is surface integral rho s into ds divided by 4 pi epsilon naught into epsilon R into R squared into AR vector. Now for volume charge, E is equal to triple integral rho v into dv divided by 4 pi epsilon naught into epsilon R into R squared into AR vector. Just look here. So instead of putting the triple integral here, I am using single integral with the suffix v for easy writing. Thank you.